The most dangerous weapon in the entire American arsenal is not carried on an aircraft carrier or launched from a fighter jet. It sits inside an 84-foot section of pressure hull, hidden hundreds of feet beneath the ocean surface, aboard a submarine most people have never heard of. The Virginia Payload Module transforms a single attack submarine into a 40-missile strike platform capable of deploying hypersonic weapons at Mach 5 without ever surfacing. No adversary on Earth can detect it. No existing defense system can stop what it carries. But only 2 shipyards in America can build it. The production line is years behind schedule, and the clock is running out. Here is what is at stake. Right now, at 2 shipyards on opposite sides of the Atlantic seaboard, teams of welders, engineers, and nuclear technicians are building the most heavily armed attack submarines in American history. Each one stretches 461 feet from bow to stern. Each one displaces over 10,000 tons submerged. And each one carries 40 Tomahawk cruise missiles, more than 3 times what any Virginia-class submarine carried before. The weapon that makes this possible is called the Virginia Payload Module, an 84-foot section of pressure hull packed with 4 massive vertical launch tubes inserted directly into the middle of every new Block 5 Virginia-class submarine during construction. It is the single largest increase in attack submarine firepower since the Cold War. The United States Navy needs it operational yesterday, because in the next 3 years, the 4 Ohio-class guided missile submarines that currently carry 60% of America's undersea strike capacity are heading for retirement. When those 4 boats go dark, 616 Tomahawk missile cells vanish from the fleet overnight. The Virginia Payload Module is the only thing standing between the world's most powerful navy and a gaping hole in its ability to strike targets from beneath the ocean. Building these submarines requires something no other nation on Earth can do. It requires cutting, shaping, and welding high-yield steel rated to withstand the crushing pressure at depths the Navy won't publicly disclose, with tolerances so tight that a single flawed weld on a single hull cylinder could turn a $5 billion warship into scrap metal that never dives. It requires 2 shipyards, a workforce of over 50,000 people across hundreds of suppliers, and a construction process so complex that each boat takes more than 6 years to complete. And right now, that process is falling behind. Here is how the United States Navy builds the most dangerous attack submarines ever to prowl the deep ocean, and why the race to build them fast enough may be the most consequential industrial challenge in American defense. The Virginia Payload Module is not a bolt-on upgrade. It is not an equipment package welded to the outside of an existing submarine. It is an entirely new section of nuclear-rated pressure hull, 84 feet long, maintaining the full 34-foot diameter of the Virginia-class hull, fabricated from scratch and integrated into the submarine during modular construction. Every Block 5. Virginia, equipped with the Virginia Payload Module, is built from the keel up with the module designed into its structure. The wiring, the piping, the ventilation, the combat systems, all of it is engineered from day one to accommodate that extra 84 feet of weapon space sitting between the operations compartment and the reactor. Inside that section sit 4 vertical launch tubes, each 87 inches in diameter, the same diameter as the tubes in the bow and, critically, the same diameter as the common missile compartment tubes being built for the Columbia-class ballistic missile submarine. That commonality is deliberate. It means the Navy can standardize its missile canister system across the entire submarine fleet. Each Virginia Payload Module tube holds 7 Tomahawk cruise missiles for 28 additional rounds. Add those to the 12 Tomahawks carried in the 2 bow Virginia payload tubes, and a single Block 5 Virginia goes to sea with 40 cruise missiles. For perspective, that is more than a guided missile destroyer carries, but Tomahawks are just the beginning. Those 87-inch tubes were designed to be multi-mission. Each one can carry 3 conventional prompt strike hypersonic missiles, weapons capable of striking targets thousands of miles away at speeds exceeding Mach 5. That means a single Block 5 Virginia could deploy up to 12 hypersonic weapons from the ocean floor without ever surfacing. The tubes can also launch large-diameter unmanned undersea vehicles too big for a standard 21-inch torpedo tube, carry special operations equipment, and deploy future payloads the Navy has not yet publicly described. The Virginia Payload Module does not just add firepower. It transforms an attack submarine into a multi-domain strike platform. And here is where the strategic math gets urgent. The 4 Ohio-class SSGN boats, Ohio, Michigan, Florida, and Georgia, were converted from ballistic missile submarines in the early 2000s. Each one carries 154 Tomahawk missiles in 22 modified launch tubes. Combined, that is 616 cruise missile cells deployed on just 4 hulls. Those boats were scheduled to begin retiring in fiscal year 2026, with all 4 gone by 2028. Recent reporting suggests the Navy may be extending their service lives due to overwhelming demand, but the clock is still ticking. When the last SSGN leaves the fleet, America loses 60% of its undersea strike capacity in a single stroke. If you are watching this and you support what we do here, covering the technology and the people that keep America's submarine force the most powerful in the world, take a second and hit subscribe. It costs you nothing, but it makes a real difference for this channel. Now let's get into how they actually build these things. The construction of a Virginia-class submarine begins not with a hull, but with steel. Raw plates of HY80 or HY100 high-yield steel arrive at Electric Boat's Quonset Point facility in Rhode Island, a 400-acre campus employing over 8,000 workers. HY80 has a minimum yield strength of 80,000 pounds per square inch. HY100 pushes that to 100,000 pounds per square inch. This is steel engineered to resist the crushing forces at depths the Navy officially describes only as greater than 800 feet, though analysts estimate actual test depth significantly exceeds that figure. The numbers are classified. The capability is not theoretical. At Quonset Point, those steel plates enter the automated steel processing facility, where digitally controlled machines cut, bend, and shape them into massive pressure hull cylinders. Design data flows electronically from Electric Boat's engineering headquarters in Groton, Connecticut, directly to the fabrication floor. Every cut is calculated, every bend is measured. The margin for error on a cylinder that must hold atmosphere at crush depth is functionally zero. Once formed, each cylinder is positioned vertical, standing on end like a grain silo, so crews can install internal components from above. Tanks, piping systems, propulsion machinery, auxiliary equipment, and hull coatings all go in while the cylinder stands upright, with overhead cranes lowering components into position. When that vertical outfitting is complete, the cylinder is rotated to horizontal ship position and receives its deck package, the pre-built equipment module that slides into the hull like a drawer into a cabinet. Multiple outfitted cylinders are then joined together to form super modules. In the early days of the Virginia program, each submarine was built from 10 separate hull sections. Starting with Block 2, Electric Boat and Newport News consolidated that down to 4 major supermodules, a redesign that saved roughly $300 million per boat. The VPM section is fabricated in a dedicated 30,000 square foot building at Quonset Point, purpose-built for $28 million as part of a $700 million expansion. The missile tubes themselves come from BAE Systems in Louisville, Kentucky, and BWX Technologies, the same suppliers building components for the Columbia-class program. Here is the part most people never consider. These supermodules are not all built in the same place. Electric Boat builds engine room and control room sections. Newport News Shipbuilding builds the stern, torpedo room, sail, and bow. Completed supermodules weighing thousands of tons are loaded onto a custom-built ocean transport barge called Holland. The barge is 400 feet long and 100 feet wide. It was delivered in 2021 specifically for this purpose, and the modules are shipped between facilities by tug. When all 4 supermodules arrive at the assembly yard, they are aligned, joined, and welded together to form a single pressure hull. That moment, pressure hull complete, is the milestone that determines whether the submarine will hold together at depth. On December 16, 2025, HII Newport News announced pressure hull complete on USS Oklahoma, SSN 802, the first Block 5 Virginia. Oklahoma does not carry the Virginia Payload Module. She receives acoustic superiority upgrades only. The first submarine with the Virginia Payload Module is USS Arizona, SSN 803. She is under construction at Electric Boat. Her keel was laid on December 7, 2022, Pearl Harbor Remembrance Day. As of February 2026, no Block 5 submarine has been delivered to the Navy. The most recent delivery was USS Massachusetts, a Block 4 boat, in November 2025. That brings the total to 25 Virginia-class submarines delivered. At least 16 more are under construction or awaiting delivery. But here is where this story turns from engineering triumph to strategic crisis. China is not waiting. The People's Liberation Army Navy operates approximately 60 submarines today, 6 nuclear ballistic missile boats, 6 nuclear attack submarines, and 48 conventional boats. The Pentagon projects that fleet will grow to 80 by 2035, with nearly 20 nuclear-powered. And China is not just building more submarines, it is building better ones. The Department of Defense confirmed 4 Type 093 Bravo-guided missile submarines launched between May 2022 and January 2023. Naval News estimates 7 in service by late 2025, produced at a rate of at least 2 per year. Each carries roughly 12 vertical launch tubes capable of firing YJ-18 supersonic anti-ship missiles and CJ-10 land attack cruise missiles. In February 2026, satellite imagery confirmed the first Type 095 hull at Bohai Shipyard. It features a pump jet propulsor, X-tail rudder, and advanced sonar. The facility has parallel assembly lines for up to 6 submarines simultaneously. Russia adds a different dimension of pressure. 5 Yasen M-class submarines are now commissioned, with Perm launched in March 2025 as the first boat built with 3 M22 Zircon hypersonic missiles as standard armament, weapons reportedly capable of Mach 6 to 9 at a range of 1,000 kilometers. Each Yasen M carries up to 40 cruise missiles. Russia is increasing submarine-launched cruise missile capacity at exactly the moment America is losing its own. Before we continue, if you found this valuable so far, hit that like button. It takes 1 second, and it tells the algorithm to show this to more people who care about American defense. Let us keep going. The reason this matters was laid bare in January 2023, when the Center for Strategic and International Studies published the results of 24 wargame iterations simulating a Chinese invasion of Taiwan. The finding that shook the defense community was blunt. Surface ships were devastated. Both forward-deployed aircraft carriers were typically destroyed in the opening phase. But submarines penetrated Chinese defensive zones and inflicted catastrophic damage on the invasion fleet. The study's conclusion was unequivocal. Without American submarines, Taiwan cannot be defended. But the wargame also exposed a critical weakness. Submarines carry a limited number of munitions and must periodically return to port to rearm, a dangerous, time-consuming process during active combat. This is precisely the problem the Virginia Payload Module solves. Tripling the missile load on each boat from 12 to 40 means fewer rearming runs, more time on station, and more firepower delivered per deployment cycle. Distributed across 20 or more VPM-equipped hulls, that strike capacity becomes almost impossible for an adversary to neutralize. The math demands it, but the industrial base is struggling to deliver. The Virginia-class production rate stands at 1.13 boats per year, barely half the goal of 2 boats per year. The Navy has not delivered 2 Virginia-class submarines in a single year since before the pandemic. A 2-year gap between April 2020 and February 2022 saw 0 deliveries. Block 5 construction spans are running 70 to 74 months per boat. Costs have climbed from an original target of roughly $3 billion to approximately $5 billion. The April 2025 contract for the final 2 Block 5 boats, SSN 812 Baltimore and SSN 813 Atlanta, totaled up to $18.5 billion for just 2 submarines. And Virginia is not even the top priority. Columbia-class is. The lead boat, USS District of Columbia, is now 17 months behind schedule, with delivery pushed to 2029. In any resource conflict between Columbia and Virginia, Columbia wins, because nuclear deterrence is existential. That means every workforce shortage, every supplier delay, every welding bottleneck hits Virginia-class production first. The numbers tell the story of an industrial base that was hollowed out and is now being asked to perform miracles. Only 2 shipyards in the United States can build nuclear submarines. The supplier base has shrunk from 17,000 companies in the 1980s to roughly 5,000 today. Only 3 vendors in the entire country produce the specialized castings needed for submarine hatches and trunk components. Federal data shows ship and boat building employment has fallen 36% since 1980. Electric Boat currently employs 25,000 workers and plans to hire 8,000 more in 2026. That pushes the company toward a peak workforce of 33,000, numbers not seen since the Reagan era. The company hires 700 to 1,000 welders every year, trains them in-house, and maintains an 89% retention rate against an industry average below 50%. But Navy officials estimate the submarine enterprise alone needs 100,000 new workers. Congress has responded with money, $5.7 billion in emergency submarine industrial base funding in December 2024, $3 billion from Australia under AUKUS, nearly $10 billion total programmed through fiscal year 2028. A new shipyard facility outside Mobile, Alabama, targeting 3,000 jobs, a new hull fabrication building at Quonset Point, a new Columbia assembly building at Groton. The investment is massive. The question is whether it is fast enough. Because every month a VPM-equipped Virginia arrives late, the gap between what America needs undersea and what America has undersea grows wider. The Navy's own force structure assessment calls for 66 attack submarines. The fleet currently has 47 to 49. That number is projected to drop to 46 or 47 by fiscal year 2030 before it begins to recover if production targets are met. They have not been met yet. These are not abstract numbers on a congressional budget spreadsheet. These are real submarines built by real people carrying real weapons that real sailors will take into harm's way. The welders at Quonset Point shaping pressure hull cylinders from HY80 steel. The engineers at Groton integrating 4 super modules into a single watertight vessel. The technicians at BAE Systems in Louisville assembling 87-inch missile tubes that will hold Tomahawks and hypersonic weapons hundreds of feet beneath the ocean surface. The 25,000 workers at Electric Boat and the thousands more at Newport News who show up every day knowing that the submarines they build must work perfectly, because the crew aboard cannot surface to fix a welding flaw at crush depth. The Virginia Payload Module is the most significant upgrade to American attack submarine capability in a generation. 84 feet of hull, 4 launch tubes, 28 additional missiles per boat, the capacity for hypersonic weapons, unmanned vehicles, and payloads that have not yet been publicly named. When Block 5 Virginias finally reach the fleet, they will carry more firepower than any attack submarine ever built by any nation. China knows this, Russia knows this, and neither has an answer for a submarine they cannot find, carrying weapons they cannot stop, operating in waters they cannot control. The only question is whether America can build them fast enough. If you want to stay informed on the submarines, weapons, and people defending this country beneath the waves, subscribe to the channel. Next week, we go inside the most dangerous job on a nuclear submarine. You do not want to miss it.